morning everyone. Today I'm going to taking the topic as cloud computing basics. Okay, so in first topic, cloud computing means it is mainly used for data storage purpose. So the main nowadays in real life, there are so many applications are using, and in real time we are using the cloud computing means it was storing the high data. So it is very useful. So cloud computing means it is data storage and computing power without direct active management by instead of your computer hard drive. So that means the databases, there are more data has been given means we are not stored in that much data in particular databases. So if that time we are using the cloud computing means it stores high data, so we are preferring the cloud computing. The best example, in aeroplane we are using the black box, right? So in that black box we are using the cloud computing because there are so many data are present in that black box. So if you are used some different type of database means it's not having that much storage, so we not stored the highest data. So if we prefer the cloud computing means it's storing more data. Then next one is technologies for network based system. There are multi-core CPU and multi-threading the technologies. Then next one was GPU computing, then memory storage and wide area network, then virtual machine and virtualization middleware, then data center virtualization for cloud computing. So the multi-core CPU and multi-threading technologies. In this multi-threading and multi-core, it was somewhat different areas of cloud computing. Then in multi-core, they are using computer or processor. It's containing one or more than logical CPU core. Then this is the multi-threading technologies. Here I mentioned 5 threads. So the thread 1, thread 2. So the difference were given here. And the first one was 4 superscalar processor. The second one was fine-grained multi-threaded processor. Then coarse-grained multi-threaded processor. Then dual core. Then simultaneous multi-thread processor. So in traditional, we are using the 4 superscalar processor and fine-grained multi-thread processor. Then in between we are using the coarse-grained multi-thread processor. Then nowadays we are using the dual core 2 processor CMP, because here in this we are connecting so much of threads. So if comparing to the traditional, this dual core having simultaneous connection, simultaneous processor will be connected here. So this is the multi-thread technology. Then GPU. GPU is nowadays we are using many applications. We are using the GPU. So GPU, that means graphic processing unit. It is a specialized electronic circuit. If we are not drawn or not seen anything means using this GPU, it will given a high output. So compared to your standard computer with processing CPU processing unit, GPU has a parallel structure that offer faster computing. So comparing to the CPU, the GPU has given the parallel structure. That means the computing was increased and efficiency also increased. Comparing to CPU, GPU was increased. So this is the one diagram of GPU. Then next one, GPU multi-core plus GPU 1000 of course. So in traditional they are using CPU multi-cores. So here they containing the 8 cores only. But in GPU we are containing 1000 of cores. So it having high efficiency comparing to the CPU multi-core. GPU has 1000 of cores. So we are connecting so much of data. Then next one, GPU program model. So multiprocessor 1 and multiprocessor n. Here having device memory. Then after that main memory. Then it's moving to CPU. So here only main memory, then CPU. That's all the connections. But here in GPU we are having device memory. Then the multi-core. That means the processor was more. Then memory storage and wide area network. So we are known. So there are LAN, WAN, MAN, like that, WAN also. So in internet connection, the large network connection, we are using the wide area network here. Then virtual machine. So virtual means the best example, here we are using the computer, right? So we are bought on computer means that we are having one Windows OS. So if we need to include some other OS in that same computer means we are going to prefer the virtual mode. So virtual mode means if the open source OS we are included in the computer. So in one computer we are having the two OS means that we call it as a virtual machine. Okay, so in one computer we are having Windows. In that same parallelly we are going to install the open source OS like Unix, Linux, so that and all virtual mode. So here the virtual machine offer novel solution to underutilized resource, application flexibility, software manageability and security for physical machine. So in physical machine we are including some virtual OS. So this is the example of virtual. Next, virtualization, having large cluster, grid and cloud. So the networking resource in a virtual manner. So it access large amount of computing and storage. Then this is the virtual machine architecture. So in physical machine, here I have mentioned the four virtual machines. The first one was physical machine, native virtual machine, hosted virtual machine, dual mode virtual machine. So in physical machine, how it was used means the space. Okay. So hardware, then operating system, then application. This is the diagram and mentioning of physical machine. In native virtual machine, we are using the hardware VMM. So this is the new process here involved. That is the hypervisor, then guest OS, then guest applications. Then hosted virtual machine, we are using the hardware, host OS, VMM, then guest app. So here the guest OS was not present in the hosted virtual machine. Then dual mode virtual machine. Now we are using this dual mode virtual machine. That means in one computer we are installing the two OS. That is the dual mode virtual machine. Hardware, host OS, there itself the VMM is present. Then the next virtual machine, then guest OS, then guest applications. So here in virtual machine, we are showing the traditional to nowadays how we are using the virtual machine concept. So this is a data center virtualization of cloud computing architecture diagram. Then next one, data center virtualization. So the large data center built 1,000 servers. Okay, so the key benefits are here. First one was reduce hardware vendor lock, improved disaster recovery, smooth migration to cloud, reduce data center footprint, faster server provisioning. Then system model for distributed and cloud computing. So here finally it built over a large number of autonomous computer nodes. So it was interconnected by SAN, LAN or WAN. Next one, system models. Here cluster of cooperative computing, grid computing, peer-to-peer network, cloud computing over the network. The first one was cluster of cooperative computing. Here the group of servers are combined together through LAN, SAN and NAS. Okay, so that means the internet, right? So nowadays we are the more important was internet. So here through that internet, the cluster and server are present here. That means input output device disk array. Okay, so these are all the cluster and internet through which method we are connecting. Here we are using the gateway concept to connecting the network to SAN, LAN, any networks to the internet. Next one, grid computing. It is a subset of distributed computing. So here the grid computing is there. Then it will connect the laptop, database, supercomputer and PCs. So the that means the distributed computing means it will connecting the network to different types of concepts. That means database, laptop, all the concepts are connected here. So that is the subset of distributed computing. Next, here the users. the telecommunication organization, government office, multinational companies and finance organization. Then grid computing was cloud computing. So this is the difference. The user management in grid computing, it was this decentralized management. In cloud computing, it is a centralized management. Then dependency, it's other computer. Here totally dependent on internet. So cloud means the internet only. So it totally dependent on internet. Then operation, it is a corporate network. It operates through the internet. Then accessibility through grid middleware, here through standard web protocols. Then domain, it contains multiple domains, it contains single domain, because single domain means it is an centralized management. So multiple domain means decentralized management. Who are all present here? Present there, all they getting the information. That is a decentralized management. But in single domain, it is comes under from the centralized management. Then scalability, it was normal and it was high. Then architecture, it is a distributed computing architecture. This is client server architecture. Distributed computing means, that means peer-to-peer network. So without the third party. Thank you.